Wow! Have you ever heard this? Scientists have made light solid. Yes, you heard that right. Light, the stuff that brightens our day. They made it act like a solid thing. It's a brand new discovery. So new, it's almost like magic. It is even called brighter than white. This is not a tale from a storybook. It is real cutting-edge science. Clever scientists in Italy did this. They worked in a special lab. It's a huge moment for physics. This changes how we see light. Imagine light with a structure. It's a truly fantastic breakthrough. Usually light just shines all around, or it passes straight through windows. We don't think of it as solid. But this new solid light is different. It behaves in a special way. It actually has a fixed structure, like tiny glowing crystals. This is a whole new state for light. This discovery is super exciting for us all. It's like opening a new door. A door to a world of wonder. It brings so many new questions, and so many new possibilities too, for future science and cool technology. Let's explore this amazing solid light, and see what makes it so special. So, what is light normally like? Before we talk more about solid light, let's remember some basics together. Light is a fascinating thing, you see. Sometimes it acts like a wave, spreading out just like ripples. Ripples moving across a calm pond, energy traveling through space. But that's not the whole story. Light can also act like particles, tiny little packets of pure energy. These particles are called photons. Think of them as light's messengers, zipping around at super fast speeds, the fastest speed in the universe. Each photon carries a bit of light. This dual nature is super cool. Light as a wave and a particle too. Scientists call this wave-particle duality. It's one of physics' biggest puzzles. How can it be two things at once? It depends on how we observe it, or what experiment we are doing. Light keeps surprising us all. But here's the thing about photons. We usually think of them as massless. They are pure, zippy energy, not something that forms a solid, or something that has a fixed shape. They just travel and spread out. That's why solid light is so wild. It makes us rethink light itself. So, how did they do it? How did scientists make light solid? It sounds like a secret recipe, but it's all about clever physics. The team was in Lecce, Italy. They used some very special tools. Powerful lasers were part of it, and unique engineered crystals too. These brilliant scientists took a laser, a very focused beam of light. They shone it through a special crystal. This crystal was made of gallium arsenide. It was designed very carefully to interact with light photons. Inside this crystal, magic happened. Well, not magic, but amazing science. The photons from the laser entered. They didn't just pass through it. Instead, they mixed with the crystal. They interacted with its atoms deeply. This created something brand new, hybrid particles called polaritons. These polaritons are part light, part matter. A little bit of photon, a bit of atom. These polaritons are the true stars. They are the key to solid light, because they have some matter-like traits. They can interact with each other, much like atoms can bond together, under very specific controlled conditions. They arranged into an ordered pattern, forming the structure of solid light. This new solid light is extra special. It's not just any kind of solid. Scientists call it a super solid. That sounds incredibly cool, right? It means it has dual properties. The photons act like a solid, but also like a strange fluid, all at the very same time. Imagine a crystal made of light, with a neat repeating pattern. That's the solid part of it. But now imagine this crystal flowing smoothly, without any friction. Like a perfect, frictionless liquid. That's the superfluid part. A ghostly flowing crystal of pure light. To see this amazing state though, scientists needed some extreme measures. The experiments had to be cold. Really unbelievably cold, in fact. We're talking near absolute zero. That's minus 273.15 degrees Celsius. Colder than anything you can imagine. At these temperatures, quantum physics rules. Why does it need to be so cold? The cold calms everything right down. Atoms and particles move less. They have much less jittery energy. This allows delicate effects to show, like polaritons forming a structure and behaving as a supersolid. Without the chill, it wouldn't happen. So why is this discovery so vital? Why does making solid light matter? It's more than just a cool trick. It truly opens up new frontiers for science, for technology, for us. It could change how we use light and how we understand the universe. The possibilities are simply dazzling. Think about future technologies now. This could lead to new light devices, super efficient lights and displays, perhaps giving us that brighter than white look. It might also boost quantum computing, using light for powerful calculations or even for new communication methods. The potential is simply enormous. Solid light also teaches us more about fundamental physics itself. How does light interact with matter? How might it behave near black holes, where gravity is incredibly strong? These are big cosmic questions. This research gives us new tools to explore these deep mysteries. This journey into light's new state shows how much there is to learn. Science is always full of surprises, pushing the limits of our knowledge. The creation of solid light shines. It's a beacon of human curiosity and our amazing ingenuity too, lighting the way to a future of wonder.